If you watch the video on the calculator, it shows you how to find the mean and the median using the calculator, which is the fastest and most accurate way probably of making sure you're getting the right answer. So we calculated that the mean was 5.64, which we rounded, and the median was 5. And then I said I would leave the mode to just looking at the actual list. And just by looking at it, it looks to me like 3 happens the most. So I see 1, 2, 3, 4 threes, and the next closest thing is 7. There are 3 sevens. So the mode would be 3. Now the question actually asked us to rank them from least to greatest. So the mode is the least, so that would go first. And that is less than the median, which is 5, which is less than the mean, which is 5.64. So this right here would actually be our answer. If you watch the video of the calculator on the right, you will see that we calculated the mean and the median. The mean came out to be 70.6. The median is 71.5. And then the mode we can calculate by looking, or not even calculate, we can just figure it out by looking at the list. Just by looking at the list, I can see that 72 happens 3 times. Here, here, and here. And the only other number that repeats is 71, which only happens twice. So 72 is definitely the mode. Now this problem asks us to rank them from greatest to least. So the greatest is the mode, so we'll put that first. And now we're going to have a greater than sign. The next biggest value is the median. And then the smallest is the mean. There are 2 ways to do this problem. I'm going to do problem 3 the long way, and then I'll do problem 4 using sort of a shortcut. So the long way would be to turn this frequency table into a list. So I would, next to each row in this frequency table, I would write out all the numbers. So remember that the frequency is telling you how many times the number in the first column are written. So the first column tells me that 1 is written once. The second column tells me that 4 is written 5 times. So I'm going to write 4 5 times. The third row tells me that 5 is written twice. And the last row tells me that 7 is written once. So now in order to calculate the mean, I would add up all my numbers and divide by how many numbers there are. So I'm going to do that down here. So 1 plus 4 5 times, plus 5 twice, plus 7 once. And then if you count how many numbers that I have here, there are 9 of them. And when you add this all up in your calculator and divide by 9, you end up getting 4.2 repeating. But if you look up in the original question, it asks you to the nearest integer. Integer means whole number here, so 0.2 would round down to 4. So my final answer would be 4. This is exactly like question 3, but I'm going to show you somewhat of a shortcut. It doesn't save you too much time. So we're going to find the mean to the nearest integer. So what we're going to do is take all of these numbers and we're going to multiply them by their frequencies. So we're going to take the ages and multiply them by their frequencies, divide by how many frequencies there are, and that will be that. So I'm going to take 12 and multiply it by 1, plus 14 times 1, plus 16 times 3, and finally 17 times 4. So those are my numbers, and what this does is it saves you from having to write 16 3 times and 17 4 times. So it saves you a little bit of writing. And then we're going to divide it by 9, because if you look at all of the frequencies, so take these numbers right here, 1 plus 1 plus 3 plus 4 equals 9, so that's what we're going to divide by. And when you calculate this out, you end up getting 15.7 repeating. And 0.7 would round up, so the nearest integer would be 16. So we're trying to find within how many standard deviations from the mean all the values fall. We're talking about tickets sold to the homecoming dance each day. So the first thing we need to do is calculate the mean and standard deviation, which I would highly recommend using your calculator to do. When you use your calculator, you will find that the mean is 41.6 and the standard deviation, and by the way, the mean, I could have used that symbol, and then standard deviation, and the symbol for that is S, is 9.8. And I rounded these to 1 decimal place. You can round them to whatever you want. I would recommend 1 or 2, unless it specifically tells you to round it to a specific decimal place. Okay, so first thing I'm going to do is label my normal curve. So the mean is 41.6, that goes in the middle. And then going to the right, I would have 51.4, 61.2, and 71. Going to the left, I would have 31.8, 22, and 12.2. All right, so next piece of information I need are the smallest and largest values in my list of data. So it looks like the smallest is 29, and I'm going to put that on my normal curve. So 29 would fall between 22 and 31.8, so I'm just going to put a green dot here for 29. And then I need my largest value, which looks like 62. So I'm going to put that, let's see, that would fall here between 61.2 and 71. So now I can look at my picture and I can see that 29 is actually within 2 standard deviations, but 62 is within 3 standard deviations, and we have to choose the larger. So the answer to this would be that your data falls between 3 standard deviations of the mean. So that would be your final answer. We're trying to figure out within how many standard deviations from the mean all the values fall for the longest distances run by each member on the cross-country team throughout the season. So there will be a video on the left that you can watch to figure out the mean and standard deviation on your calculator. The mean is 5.04 and the standard deviation is 1.91. Now on the previous slide I rounded to the 10th or the first decimal place. I rounded this one to 2 decimal places, mostly because I didn't want to round the mean to just 5 even. But it really doesn't matter because ultimately we're just trying to figure out how many standard deviations it falls within the mean, so that shouldn't affect it depending on how you round. So now I'm going to label my normal curve. 5.04 goes in the middle. Going to the right, I would have 6.95, 8.86, and 10.77. Going to the left, I would have 3.13, 1.22, and negative 0.69. There is a negative number down there, and that's fine. None of the runners ran negative distances, so that's not where any of our data is going to fall, but it's okay that it's on our horizontal axis for the normal curve. So now I need to identify the largest and smallest values. So I'm going to start with the smallest, which is 2.9. 2.9 would fall here in between 1.22 and 3.13. And then I also need to figure out the largest, which is 8.4. 8.4 would fall between 6.95 and 8.86. So it looks like both of them fall within 2 standard deviations of the mean. So my answer would be 2 standard deviations. We're trying to find the z-score. We're given that the mean is 32 The standard deviation is 4, and the value we're trying to calculate the z-score for is 29. So this is actually not a terrible problem. All you have to remember is the z-score formula, which is that you take the value minus the mean and divide by the standard deviation. And then we want to round to 2 decimal places, because that z-score table is what we're going to use to find the percentage in a problem that would ask us to do that. And so we want 2 decimal places. So here we go. Z-score, the value is 29. We're subtracting the mean, which is 32, and we're dividing by 4. So when you calculate, you get that this is -3 over 4. So this would be -0.75. So this one we didn't have to round because it just came out to be 2 decimal places. So that's our answer. Same question as number 7, just different numbers. So the mean that they give us is 125. Standard deviation is 4. And the value we're trying to calculate the z-score for is 134. So again, the formula for the z-score is to take the value minus the mean and divide by standard deviation. So I'm going to take 134 minus 125, and we're going to divide by 4. 134 minus 125 is 9, and when you divide that by 4, you get 2.25. So again, we didn't have to round to 2 decimal places because it automatically was. So you were given the class average for your Unit 1 test. It was an 83 with a standard deviation of 4, and we're trying to figure out what % of students got a score less than 76. So at first glance, this looks like a normal curve problem where you label your normal curve and then you add all the percents less than 76. So if you started out that way, you would write that your mean was 83, that's in the middle, standard deviation of 4, so you would go 87, 91, 95, and then 79, 75, 71. Okay, now we're trying to find the % of students that got a score less than 76, and if you notice, 76 is not one of the numbers on my normal curve. When this happens, it means this is a z-score problem. So we're going to cross out this normal curve. It doesn't mean that our data is not normal. It just means that we can't find our answer using this normal curve. So what we're going to do is we're going to calculate the z-score. So the z-score, remember we're taking the value minus the mean over the standard deviation. So in this problem, the value we're looking for is that 76. The mean up here is 83, and standard deviation is 4. And when you do the math here, you end up getting -1.75. That's our z-score. But we can't stop there because it actually asks us for the %. So down here at the bottom, this is the z-score table. I just have the -1.7 row snipped out so you can see it. And I will label these things so you can kind of see what I'm talking about, since I didn't put the whole chart in here. So up at the top here, this would be 0.00, 0.01, 0.02, 0.03, 0.04, and 0.5, which is actually the one I want. So I want my -1.75. So this % right here is what I want, but that's the decimal, and I want the actual %. So the answer is 0.0401, but I have to move the decimal over twice to turn this into a %. So my answer would actually be 4.01%. So that's what percentage of students scored less than a 76 on the first unit test. Scores on the SAT form a normal distribution with a mean of 500 and a standard deviation of 100. What % of students will score above 729? So at first glance, this looks like a normal curve problem, but if you label your normal curve with 500 in the middle and then a standard deviation of 100, you'll notice that 729 is not on your normal curve. So when this happens, this turns into a z-score problem. So to find the z-score, you take the value minus the mean divided by the standard deviation. So in this particular problem, our value is 729, mean is 500, standard deviation is 100. And when you calculate this out, you get a z-score of 2.29. Now, that is not our final answer because it actually asks us for the percent that will score above 729. Now, one thing to be really careful about is it asks you what percent will score above 729. Z-score will tell you what percent scored below 729. So when we get our final answer, we're going to have to take that percent and subtract it from 100. So down here at the bottom, this is the one line that is applicable to what we're doing. This is the 2.2 line in the table. And this would be 0.0001. And so all the way at the end is the one we want, which is 0.09. So this number right here would be our 2.29 z-score. So the percent is 98.9%. But again, if you look at it, right now it's a decimal, 0.9890, but we're going to move the decimal point over twice. So it actually is 98.9%. But remember, that is the percent of students who score less than 729. So this is the percent that score below 729. And we want the percent that scores above. So what we're going to do is take this percentage here and we're going to subtract it from 100. So 100 minus 98.9. And when you do that, you get 1.1. So 1.1% is the actual answer to this problem, and that is telling you the percent of students who will score above 729 on the SAT. We need to identify the following variables as quantitative or categorical. So I'm just going to go through and use either a Q or a C. Q for quantitative, C for categorical. So remember that anything that is a number could potentially be quantitative. But it could also be categorical. You have to determine if it's something that's measurable. If it's not something that is measurable, then it's categorical. All right, so Social Security number is a tricky one. It is a number, but it is assigned to one specific person. If you found the average Social Security number of your class, it would be nonsense. It wouldn't mean anything. So Social Security is categorical. Heart rate, something you can measure. If you wanted to find your average heart rate for the day, it would be meaningful. It would tell you kind of where your heart rate is throughout the day. So that would be quantitative. Test scores are quantitative. Those are things that you can find the average of. Hair color is not a number, so it's automatically categorical. 5K race times would be something you can measure, and it's something, if you took the average of it, it would be meaningful, so that's quantitative. And credit card number is another one like Social Security number. It actually is categorical. The credit card number is just kind of a random number that's assigned to your account. If you took the average of a bunch of people's credit card numbers, it would mean nothing. We are asked to determine which measures of center are equal. Measures of center are mean, median, and mode. So we have to calculate all three of them and then determine which ones are the same. This one specifically asks us to show all of our work to support our answer. So even though you may want to do the work in your calculator to double check, you do need to have this one written out if you were going to receive full credit on the test. So let's start with mean. There's two different ways you could do this dot plot. I think, just writing it out as a list would not be a bad idea. So we're going to write out all these numbers. So 39 plus 40 plus 42 plus 43 twice. And then it jumps to 47, 48 three times. And it jumps to 50, 51, 53, 54 twice, and 55. And we're going to add up all these numbers. There are 15 of them. So we're going to divide by 15. When we divide all this out, you're going to get 47.6. Oops. 47.6 repeating. Okay, so we're done with mean. Now we need to find median. There are 15 numbers. 15 divided by 2 is 7.5. So that means the middle number would be the 8th number. So what we can do is just count in 8, or you can cross off dots going both directions. Either way, you should end up with the same information. So I'm going to count to the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. So here's my 8th number, and it falls as 48. So that means my median is 48. And then last but not least, I need to calculate my mode. Mode is the easiest. On a dot plot, it's just whichever number has the most dots on it. So looks like 48 has the most dots on it. So 48 is the mode. Now the question actually asked us to say which measures of center are equal. And as you can see, the median and the mode are both 48. The mean is different. So the answer to this question would be that the median equals the mode. And then the work that supports this answer are the calculations that we just did. We are asked to determine which measures of center are equal here. That means mean, median, and mode. So we're going to calculate all three and then determine which ones are the same. So the first thing we're going to do is find the mean. We're going to add up all the numbers and divide by how many numbers there are. So remember, the numbers that you're writing are the ones on the bottom, and the dots tell you how many times to write them. So for the mean, we're going to do 3 plus 3 plus 3. We're going to add 4 3 times. We're going to add 5 6 times. And then 7, 8, and 9. And then we actually wrote down 15 numbers there. And when you add these all up and divide by 15, it comes out to be exactly 5. So the mean here is 5. Median, we're looking for the middle. There are 15 numbers. If you divide 15 by 2, you get 7.5. That means that the middle number, which is what we're looking for, is going to be the 8th number. So I'm just going to count along until I get to the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. So that means that the median is 5. So right away you can already tell that the mean and the median are equal. And then last but not least, the mode. Again, we're looking for the tallest stack of dots here. And that happens to be 5 as well. So it turns out that all three measures of center are equal. So I would say the answer is that the mean is equal to the median is equal to the mode. Justin keeps track of his quiz grades throughout the year in advanced algebra, and then it gives you a list of his quiz grades. Part A asks us to find the mean, and we're going to round to the nearest whole number. So over to the right, you'll see a video on the calculator. I'm going to use the calculator to find the mean and the standard deviation, so parts A and B. And I'm going to write down the answers. So the mean we're going to get is 86. It actually comes out to be 85.5, but we're rounding to the nearest whole number. And then the standard deviation comes out to be 8.8, but I'm going to round it up to 9. So now the next thing for part C is it asks us within how many standard deviations from the mean do all of the values fall, and then we need to draw the normal curve, which is already done for me here, and label the horizontal axis to support my answer. So I'm going to label all of my numbers. So 86 is the mean in the middle, and then I'm going to be adding 9 to go to the right, so 95, 104, 113. And then going to the left, I'm going to subtract. So I would have 77, 68, and 59. All right, so now at this point, I need to find the smallest and largest values in my list. The smallest value looks like 67. And 67 would fall right here on my normal curve. And then my largest number, I think, is 95. And 95 falls exactly on one of the lines there. So now I need to see, I'm going to take the answer of the one that's farther away. So this one is exactly 1 standard deviation away. This one is 3 standard deviations away, so my answer would be 3 standard deviations for part C. The student help desk at Joliet Central has found that the number of students it works with each day has a distribution that is approximately normal, with a mean of 74 students and a standard deviation of 5. Part A asks us to find where we expect the middle 68% of the distribution to fall. Before we can give this answer, we need to label our normal curve. So 74 is the mean that goes in the middle. And then 5 is the standard deviation. So that would make this 79, 84, 89. And then going the opposite direction, we would have 69, 64, and 59. Okay, so 68%, if you remember, that is equivalent to saying one standard deviation of within 1 standard deviation of the mean, and that is that empirical rule. So I'm looking from here to here. That's my 68%. And if you forget on the test, just remember that each of these are 34%. So if you remember the little percentages, you can remember that the two of them together is 68%. Okay, so the middle 68% of the distribution would fall between the numbers 69 and 79. The way that we know is this empirical rule. And I know, so my answer for part B would be because 68% of the data falls within 1 standard deviation. So 68% of data falls within 1 standard deviation of the mean. This is a 4-part problem. We're given a normal curve that's already labeled on the horizontal axis. For part A, it's asking us to find the mean of the normal curve. The mean is always the value that falls in the middle. So I can tell you that 52 is the mean for part A. Part B is asking for standard deviation. Standard deviation is how much it takes to go from one value to the next. So if I just look between 52 and 58, if I add 6, that gets me to 58. And you could just double check to see if you add 6 to 58, do you get 64? And then if you subtract 6 from 52, would you get 46? And you do. So that means that standard deviation here is 6. The percent of the data between 52 and 58, I would probably go through and mark off these lines so that we could figure out the percentages. So I want between 52 and 58. So here's 52, here's 58. It's only one section, and that section is 34%. And this is something you'd have to have memorized. And then it asks what percent of the data is more than 64. So I'm going to go through and I'm going to label the rest of the percentages to the right. So this is 13.5%, 2.35%, and 0.15%. So for this problem, I'm looking for everything to the right of 64. So here's 64, and I want both this section and this section. So I'm going to add those two percentages together. So that would be 2.35 plus 0.15, and that gives you a total of 2.5%. So that would be your final answer for part D. This problem is talking about the average lifespan for a female in the United States. The average is 82.2 years old and a standard deviation of 7.1. And then it asks, in a population of 300 women, how many women would you expect to live between the ages of 68 and 89.3? So let's go through the steps because it kind of walks you through the problem step by step. For part A, we need to draw and label the normal curve. So here's my average, 82.2. And then I'm going to take that and I'm going to add 7.1 going to the right, and I'll subtract it going to the left. So I have 89.3, 96.4, and 103.5. And then going to the left, we would have 75.1, 68 and 60.9. Okay, so that's part A, so that's done. What percent would you expect to live between the ages of 68 and 89.3? So before I move forward with this problem, I'm going to do all my percentages. And again, these are things you need to have memorized. Okay, so I'm looking between 68 and 89.3. So here is 68 and here's 89.3. So I need to add up these three percentages. And that's going to give me my answer for part B. So I'm going to add 13.5, 2.35, and 0.15. And when you add those up, you get 16%. So that's my answer for part B. And then in part C, it asks, of 300 women, how many would you expect to live between 68 and 89.3? So we already have our percentage, which is 16. To calculate the answer for part C, we're going to take that percentage and multiply it by 300. So 300, and then if you have a percent button in your calculator, that's fine. If not, you can change it into a decimal, 0.16, and it gives you exactly 48. So 48 women out of a group of 300 would be expected to live between the ages of 68 and 89.3. 95% of quiz scores fall between 76 and 93. Assuming the data is normally distributed, what is the mean and standard deviation? So the first thing we need to do is use this 95% to know where we would put our two numbers on our normal curve. 95% corresponds with 2 standard deviations away from the mean. So I'm going to take my two numbers, which are 76 and 93, and I'm going to put them 2 standard deviations away from the mean. So on this line and this line, we're going to put our 76 first because it's smaller, and then the 93 will go here. Now, there are a couple different ways you can do this. In my opinion, the easiest way is to find the standard deviation first. So we're going to take the larger number, 93, and subtract 76. And then we're going to divide by how many sections there are in between those blue lines. So here's 1, 2, 3, 4. So 4 sections. And then when you actually do the math here, you come out with a standard deviation of 4.25. So that's half of my answer. That's my S. And now to find the mean, we're going to take the standard deviation and we're going to add it to 76 until we end up in the middle. So if I did plus 4.25, I would get 80.25, but I'm still not in the middle. And then if I took 80.25 and I added the standard deviation again, I would get 84.5, and that is the mean because it's in the middle. So 84.5 would be the mean. All right, we are using the dot plot to answer the questions below. Part A asks us to calculate the mean, and we're going to round to the nearest tenth. I would suggest plugging all of these numbers into your calculator and having it calculate the mean for you. I did just that, and I was able to get that the mean is 53.7. So it's actually 53.6 repeating, but it asks you in the problem to round to the nearest tenth, so that's 1 decimal place. So that's part A. Part B asks us to do standard deviation and round it to the nearest hundredth, which is 2 decimal places. And off of my calculator, which I already did to find the mean, the standard deviation that they give you is 6.55. So 2 decimal places there. And then part C asks us to calculate the z-score for a president who was inaugurated at age 58. So the value is 58. The average is 53.7. and the standard deviation is 6.55. So I'm going to plug this into my calculator, and it's going to give me a positive z-score. I know that because the numerator is going to be a positive number. And the z-score that I am given here is 0.66. This again asks you to round to the nearest hundredth. So that's 2 decimal places. I actually get 0.65, but the next number is a 6, so it rounds up to 66.